Okay, I don't know who lied to me, but in the thing it said there was only going to be 15 people here. This is more than 15 people. But I'm happy to have you all here. My name's Lee Faus, Global Field CTO for GitLab. This is a topic that I'm starting to have a lot with customers. One of the big things that we're seeing is our customers want to see faster feedback loops. So we've seen a lot of studies out there that talk about things like context switching. So if I've got to move between tools and you have to take somebody out of their current mental model and they have to go from tool to tool, I have to come back. I've got to figure out where I am. Do I have to authenticate into the other tool? Things like that. And this has been even inside of GitLab, we're seeing this, even if I have to switch, let's say, between two different tabs. So over the last year, I've been working with one of our engineering teams, and what we've done is we've started building out something called Steps. And how many people here have used GitLab CI? Anybody here? Wow, cool, awesome. So GitLab CI is part of the overall GitLab platform, and our CI is broken up into 3 different layers. There's an orchestration layer, there's a workflow layer, and then there's a runner layer. The runners we can then connect. The runners you can connect to over SSH. You can use them in Kubernetes, have them be ephemeral. You can run them as Docker images. Lots of different ways about being able to execute those runner fleets. And then we can also set them up to be able to do things like I was working with a customer a few months back, and they're using things like Carpenter. And they can use Carpenter with Kubernetes, and they can automatically scale out and scale in, and they can even, using their manifest files, they can even pin specific builds. Let's say I'm doing an AI workload. I can go ahead and spin up in my cloud resources. I can spin up GPUs and attach them to GPUs. I can even pin things to certain VMs and make sure that the VM doesn't shut down while it's trying to move workloads in between the worker nodes in Kubernetes. So when we think about build automation and GitLab Steps, one of the things that we see is some of this is education, best practices, but I am a Jenkins user from back in the Hudson days. Don't blame me for any of that. So one of the things when we would build pipelines is back in the early 2000s, late 2000s, what we did is we just took our different jobs and we really just created bash scripts, and we would execute bash scripts as you would go across. And then we got really intelligent about this, and we would start to build stages, and then we would group stages with jobs, and all of that ended up becoming a big hairy mess for a lot of customers over the years. And when you would go and you would want to go in between stages and in between jobs, we had this really horrible way about thinking about workspaces, where if I think about doing things, let's say with Carpenter inside of Kubernetes, I have to now have persistent volumes. And I've got to map those persistent volumes to specific builds. So with Steps, what we're able to do is you can think about Steps as being a job inside of GitLab that's just broken down into multiple different stages inside of that specific job. So we've built this right now to be able to allow you to also have custom designed inputs and outputs. So how many people here that have built a CI pipeline and you own the stage of build and somebody else owns the stage of test, and you have some sort of mismatch because you didn't cache the right files or you didn't cache the right artifacts, and now all of a sudden all the tests are failing and you're trying to figure out why? Anybody ever run into that? Okay, got a few. So this is what Steps are trying to alleviate. What I can do is I can do all of that inside of a single job, and I don't have to worry about caching all of the individual artifacts. Or even I don't have to go ahead and, let's say, do another Git clone to be able to go ahead because I'm just in a different stage. So when we talk about software factories, the thing that amazes me is this slide, I haven't changed in 10 years. That's what really scares me, is we haven't really evolved past this slide. Software factories was a term I remember back in the late 90s. There was a gentleman by the name of Jack Greenfield who worked at Rational. And I remember I was at an event similar to this, and he talked about software factories, and everybody thought it was sort of like generative AI right now. Oh, they're trying to get rid of all the developers. And that's not what it is. The software factory, if you think about a factory, I've used this analogy in the past at different DPE events. I love Oreos. So for me, I really don't want to open up a package of Oreos that I expect to have double stuff and have it be a thin. That's just nothing more upsetting to me as to have a thin in my double stuff. So when we think about a factory, there's certain things that we do in a factory to make sure that we're always doing the same things. I've got the right measurements for the flour, the right measurements for the sugar, the right measurements for the liquids. And at the end of the day, the Oreos that come out for the double stuff Oreos will have a very consistent mark. And I know exactly how many Oreos are supposed to go into every package. That is what we're trying to get at when we go through and do build automation. And we go through all these things from issue management through source code management up through code reviews. We then do build automation to ultimately get to a package. So all of that on the left-hand side is software factories. And then on the right-hand side, this is something that I coined, which I call software logistics. Anybody here who has ever tried to define what continuous delivery means, there's a lot of things that go into continuous delivery. And now we're sort of bringing back the term platform engineer to be the person who is responsible for all things software logistics. That's environment management, release orchestration, canary builds, blue-green deployments, feature flagging. All of those things end up going into the software logistics side. And then we even get to the tail end of that, which is then going into change management. So if I've got to wait for a manual approval for me to make an update to a database, and that's sitting in something like ServiceNow, all of those things on the right-hand side make up software logistics. And across the top, we have the entire software supply chain. Now, when it comes specifically around being able to talk about the software factory side, which is where we see a lot of our customers are using tools like Gradle. Well, if I go back to that model where I have multiple different stages, if I go through and I do a build, and then I do a test, and then I do a package, if I do each one of those in different stages, I have to build a caching mechanism to be able to move everything in between those. And then if I want to report back on things like test coverage, other things, it's somewhat hard to do. There's a lot of manual orchestration that you've got to do. There's a mental model that you have to go and create. So what I want to do is I want to show, this is brand new. This is right off. We've had this in beta for a while, but we just released this in GitLab 17.4, which I think was last week. So it went GA. So you're going to create a file that is your stage file or your steps file. And inside that steps file, you're going to be able to define a spec at the top. So you can have inputs, and those inputs you can give variables. So here I'm giving a variable called name. I'm going to tell it it's a type of string, and then I'm going to give it a default. Now, as you have things that come in, you can define things in here as it's not just a string. We can do arrays. We can do integers. There's all kinds of things that you can pass in. I've got an example at the end that shows you how you could do this with Gradle. Then what you do is underneath that, so you can have multiple specs inside of here, multiple inputs. And then you've got a definition. So the definition here is I can now take the steps and I give it the name, which I'm going to give this a step name called greet user. And then I'm going to pull in the step, and this is going to be something that you can pull in like a component. So components are relatively new inside of GitLab. So these are self-contained, reusable ways, very similar to like a GitHub action, and they are composable. So the nice thing about this is you can build these components locally on your desktop, and then you can publish them into GitLab so they can become reusable. And then we define the inputs, and here I'm going to say it's typical hello world. So I'm going to hello, and then I'm going to pull in from the spec I'm going to pull in the inputs and I'm going to call the name, which was a variable that I created. So then when I go ahead and I can have another step that has a name, and you've got print system information, and I can call the step and I call out the uname from the machine that it's actually running on. So one of the things that's unique about steps is how many people here have dealt with let's say kernel issues or let's say memory issues as part of a build, right? So when we're executing those kinds of things out of Bash sort of masks a lot of the output of that I would get from that, because it's not actually running at the system level, especially if you're in an ephemeral environment like Docker. Well, one of the things that we changed with steps is instead of running these as shell executors using Bash or whatever shell you're using, we're actually calling out to exec. So because we're using an exec, I get the entire stack trace all the way down to the kernel. So if I have an out-of-memory error, we've all been there as a developer, right? It wasn't my code. It was something that's running. It's not my fault. So when we go ahead, this allows us to be able to have a lot more visibility into where that stack trace is occurring. It could be that I have ended up calling a dependency that is hitting an out of memory based on a package that's installed inside of the Docker image that's really causing the out of memory. It's not my code at all. So being able to have that visibility is critical. So this is another big difference when we're using steps, is we did this because we saw so many companies that were struggling with taking legacy Groovy files or legacy shell scripts and trying to transform that into something where they can be able to create faster round trips. So they're transforming a lot of this automation. Now, this is the piece that sort of blows some people's minds. So I could take that exact same thing. Remember we talked about having a component, so that step component? Well, now I can, inside of a step, I can also call a GitHub action. So if you go to the GitHub Actions Marketplace and you see an action that you want to use inside of GitLab, you can call a step and just put in there, we're going to default to github.com, and we're going to pull in that action automatically for you. And using the same spec with the inputs, I can take those inputs and call a GitHub action. But not only that, I can mix and match GitHub actions with GitLab components so you get the best of both worlds. So for anybody here who's, let's say, talking about building an integration, if I'm building an integration and I'm starting on GitHub and I build an action, and then you have a customer that comes on and goes, yeah, but we're all in on GitLab, and well, you can say, yeah, just use a step and just call our action that we've already created. So this gives people a lot of flexibility for when you think about how you want to integrate things into that software factory side. And because we're calling everything as a set of steps and we're using inputs and outputs between those, you don't see anything here where I would have a way that I would need to worry about caching anything, because I'm keeping everything directly. Step one gets access to everything. Step one exposes everything for step two. Step two consumes everything that was produced in step one. Step three consumes everything that was produced in step two and step one. So now you can really streamline your workflows. What we're seeing from customers who have been playing with this, number one, because we're using exec, and number two, because we're not bouncing between multiple stages and having to inflate Docker images and rebuilding environments by having to create caches and downloading things out of, let's say, S3, we're seeing an over 80% performance improvement by being able to keep everything inside of one set of steps. Now, I'm not saying, the typical infomercial, your rates will vary based on your own environment. But where we're seeing this very prominent are places where you've got compiled languages. Are you going to see this with Ruby code? No. Am I going to see this with TypeScript? No. But what about with Java? What about .NET? What about Go? What about Rust? We're absolutely seeing those types of performance improvements by being able to use these steps capabilities. So if I was to go ahead, imagine how many of you, when you go through and you say, oh, you know what, I need to create a stage for build, I've got one for test, I've got one for package. So you create 3 different stages, but underneath the hood, you're actually calling the exact same Docker images that has Gradle installed on it. Well, here what we can do is we can now build reuse by being able to have an input where I can say the project directory that I want. So I'm building a microservices architecture. I've got 5 different projects that I need to build simultaneously using a matrix type build across different JDKs. I could then have, here we've got Gradle tasks as an array, but being able to have, let's say you've got a matrix array. So I could create a matrix array, and I could not only build across multiple Java versions, but I could also build across ARM versus Intel versus AMD. I could have all of those things pre-built out as the part of the spec. And then when I go ahead and I want to execute it, all I do is I have a command that I want to run. And now when I call my Gradle command, I'm just going to go ahead and I'm going to join everything inside that default, and I'm going to iterate over the arrays, and I'm going to build different simulated jobs are going to run automatically based on what's inside that array. So now if I do it where I've got a matrix build that's in there, you're basically creating a pseudo map of I've got the steps that I want to run from Gradle, and then I have all the different combinations and permutations of environments that I want to execute against. JDK plus architecture of the OS. And again, because I'm running this instead of running it out of a shell or running it on top of a VM where I'm shelling out to a different command and I'm actually running this versus an exec, I'm able to see a lot more data. So here, when I go ahead and now inside my build stage in GitLab, I go ahead and run my steps, and my name is going to be my build project, and then the step that I'm running. And then my inputs, I'm just calling out to the projector, and it's going to go execute everything in those steps automatically for me. So now it gets a little bit confusing. If anybody has any questions, I recommend you reaching out to me. Feel free to find me on LinkedIn, on Twitter. You'll find me as Continuous Lee. I'm out there. A lot of these things now inside of GitLab, it can be difficult because you've got the GitLab CI file. Then you've got your GitLab templates file. You now have components, and now you've got steps. So you think about how you can combine those. Depending on your use case, there's all kinds of different ways about how we can use those together to be able to create a lot of efficiency. And one of the big things that I think we're missing in a lot of platform engineering conversations that I'm having with customers is we talk a lot about on the generative AI side, we talk about productivity, but we're missing a big component when we talk about efficiencies. So I can generate hundreds of thousands of lines of code, but if my build pipelines are still old, rundown pipelines, it's just going to take me longer to build and compile that 100,000 lines of code that you wrote. So if I'm able to do both simultaneously and go through and give you that type of environment, great. Now I'm able to boost your productivity. At the same time, I'm able to gain efficiencies, which now inside my environment, number one, it means less loss on the runner side, because now I'm not throwing away builds because something failed halfway through. I'm now able to get more context about it. One of the things that we just announced with our Duo workflow capability, Steps will also work with our root cause analysis. So you can take your logs, and when you see an exception that happens in the logs, we can pass that off to generative AI and make a recommendation. The last thing I want to talk about is how many people are excited about happy hour tonight? All right, happy hour. So we have a giveaway, and if you scan this QR code, we're giving away something very special. So I recommend that you sign up if you have not already. And I will be around. I will be out there. My favorite drink is bourbon. So any of the bourbon lovers out there, we'll have to create like a little group somewhere. We can, you an old-fashioned or a Manhattan guy? Yeah, there we go. So with that, I want to thank you, and hope to see you out there and answer any questions that you may have.